If there were a path to being kind of a really in-depth GIS analyst at this particular company, I might have actually stayed on that. But in this case, there really just wasn't a lot of growth potential for a straight up GIS analyst. If you wanted to move up, you had to move into project management, you had to go to personnel management, or specialize in a relevant subject matter if you wanted to kind of get promoted and really have some success.
Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. In just a minute, you're going to hear a conversation between myself and Dan Ma. And a few years ago, Dan made the jump from being a geospatial analyst, a GIS analyst, over to a software engineer. So he's going to walk us through why he did that, how he did that, and just explain some of his thought process around this and walk us through some of the things that we should be aware of if this is a path that we are interested in taking. Just before we get started today, a big thank you to my sponsor, Pictera. Pictera is a geospatial platform that lets you automatically extract features from a variety of different kinds of imagery sources. And the magic about this is that you don't have to be a machine learning expert to create these algorithms. So you simply load your imagery, you draw detailed polygons around the objects that you are interested in extracting, and the platform will do the heavy lifting for you. So if you don't have the imagery that you need, Pictera will also help you find the right imagery, whether it's free or commercially available satellite imagery, for example. And they've created this really handy free guide to Earth observation and satellite imagery data sources. And I'll put a link to that in the show notes if that's something you're interested in. So thanks, Pictera. Thank you very much for helping make this podcast episode possible. I really appreciate it. Hi, Dan. Welcome to the podcast. You have been a geospatial analyst for a number of years, but you've decided to pivot away from that and become a software engineer. And I think this is going to be a really helpful conversation for a lot of people listening, because there's always that sort of tension between analysts and software engineers. And I hope that we can dive into a few details around that and around your journey. But I think before we do that, perhaps you could tell the audience how you got involved in geospatial, how you become a GIS analyst.
Thanks, Daniel. I'm a longtime listener of the show, so really it's a pleasure to be on. Yeah, so as you mentioned, I am currently a software engineer, but for a number of years, I was just kind of a regular GIS analyst. This was my first job out of college, or I guess you'd call it university. And this was a medium-sized government contractor. They focused on the environmental sector, and they had contracts with the U.S. Environmental Protection Agency, agencies like that. Now, initially, about half of my billable hours were for GIS work, but I was just doing typical GIS analyst stuff. I was using ArcMap and ArcGIS Desktop. I was making one-off PDF maps for reports and visualizations. I did a lot of hydrological analyses, which was using the Spatial Analyst extension. I did environmental justice analyses using demographic data from the Census Bureau. It was really classic level, junior level GIS analyst type work, mixed in with some non-GIS entry level consultant work. Just really an unremarkable entry-level position.
So entry level implies that you were on the way somewhere else. You're at the bottom and there was room to grow. But what was it about this entry level position that made you think, hey, I don't know if this career path is for me, and made you want to sort of pivot over to being a software engineer?
I actually really enjoyed the geospatial component of things. I really like that kind of problem solving. Like a lot of listeners, I really enjoyed the ability to solve a problem and then see a result. It wasn't just a Microsoft Excel model or some database table. It was something that I could visualize in GIS software. So I really enjoyed that. And if there were a path to being kind of a really in-depth GIS analyst at this particular company, I might have actually stayed on that. But in this case, there really just wasn't a lot of growth potential for a straight up GIS analyst. If you wanted to move up, you had to move into project management, you had to go to personnel management, or specialize in a relevant subject matter if you wanted to kind of get promoted and really have some success.
All of which would have taken you further away from that sort of technical level of expertise that you had built up over the years, over your career, and also the things that you were interested in. So how did you get into programming? Is that something that when you started the job, you had an understanding of programming language, of geospatial programming in general, or was this something that you learnt and played around with during your time at this organization?
Yeah, that's a great question. In my undergraduate, I had a small amount of programming exposure. but it was not from experts. It was just to support my undergraduate research, which was remote sensing. This was in IDL, which is a very esoteric language that probably only the Earth observation folks who are listening recognize. But at this particular job, when I was a GIS analyst, we used a lot of Model Builder. And for anyone who's not familiar with Model Builder and ArcGIS, it's like a graphical user interface, kind of draggy, droppy way to have a pipeline of different processes where the output of one step is the input of another. Now, inevitably, one of our models got too complex for this interface. So I literally learned the basics of Python by opening Model Builder models, clicking the File menu, and then export to Python. I think this is actually the strategy that Anita Grosser mentioned when she was on the podcast last year or the year before. So over time, I started writing little macros and little custom tools in Python just for myself. It was really just to speed up my day to day work and automate the routine tasks. As an example, I was constantly doing spatial joins, right? This is a really classic geoprocessing tool that GIS analysts are using. But I was doing them just to get a single attribute. And that's a very clicky process in ArcGIS. You have to click this table and you have to click join and then you got to export it. And it's just all over the place. So I wrote a script that automated these steps. It reprojected the data so they were always in the same coordinate system. It performed the spatial join in memory, so it was relatively fast. It copied the column from the output feature class. It pasted the column back into the input feature class, and then it cleaned up all the intermediate data in one go. These handy little tools, writing these is really a great way for a novice to get their feet wet since it has an immediate, meaningful impact on your efficiency and productivity. It's really the best way to stay motivated is to see that immediate payoff. Eventually, these tools got noticed by my colleagues. I started sharing them internally. And then eventually it got to the point where I even helped win a very modest contract to write one of these ArcGIS Python toolboxes for an external client. Now, in hindsight, I had no idea what I was doing. Let me be totally clear. I was kind of winging it. I was coding these tools in Notepad++. I was using email attachments for version control because I didn't know what Git was. But everyone's got to start somewhere, and that's where I started.
So I guess my question here is how did you find, or how did you manage to carve out time? Right at the start of the conversation, you talked about billable hours. So I'm assuming someone was kind of looking over your shoulder from time to time and interested in what you were spending your time on. And the first time you write a Python script, it takes much longer to do it, right? Than it does just to click and push on the buttons. So how did you justify that or find the time to do that?
Yeah, well, it was exactly that first project, the one I talked about that was too large and too complex to fit into Model Builder. That was the opportunity where I had some billable hours to actually take the time to just learn the very basics. Now, that being said, I've spent a lot of my own time outside of my billable consultant hours in order to actually get some level of competency with making Python toolboxes and so on. So I would be lying if said that I was paid throughout the entire process, throughout the entire learning process. It really was something that I did have to do kind of on my own time as part of professional development.
What kept you going? What kept you interested in learning this? Because this can be a really steep and difficult learning curve for a lot of people. What was it about programming that captured you and motivated you?
I think it was what I mentioned earlier. It was the fact that I wasn't trying to write some grand, complex program. I wasn't following a tutorial that was doing something very abstract and very computer sciencey. I was writing tools to make my day-to-day work more efficient, to automate irritating, boring tasks that I had to do as a GIS analyst, to automate, exporting maps. I had another project where we had a collection of like 80 maps that we needed to make for the appendix of some report. And there's ways to do that using data-driven pages in ArcGIS or some of the other tools. But by using the ArcPy mapping module, I wrote a script that could batch out 80 of these with different symbology and different extents and different coordinate systems all in one script that took just a couple minutes to run. So I think it was the fact that I saw that payoff so quickly that kept me motivated to keep going and keep learning.
So you're working as a GIS analyst. You had this interest in programming. You had the opportunity to explore it and to figure it out, like during your own personal time and at work, by the sounds of things. But then at some stage, you clearly decided, hey, this isn't enough. I need to get a formal education in software engineering. What made you decide that? Like, what did you base that decision on, that it has to be a formal education in software engineering?
Yeah, that's a good question. To be clear, it was not an immediate decision. And I think this is a very important point to make for a lot of folks out there. I think there are people who hear about the Silicon Valley salaries and how much these engineers are paid, and they feel like they should quit their job and jump feet first into an expensive graduate program or the new thing, which are the programming boot camps, right? It's like buying a car without ever taking it for a test drive because graduate schools in the US are, especially master's programs, they cost way more than a car. So I think it's really important to start off with some self-driven learning from free or low cost resources. I think there's a lot of stuff that you can get for just like 50 or $100. That's exactly where I started. I kind of started taking I found these like online tutorials. The really popular one back in the early 2010s was this thing called Dive into Python. Nowadays there's a popular book called Automate the Boring Stuff with Python. And these are the kind of free low cost resources to just confirm to yourself that this is something that you enjoy, that this is something that you might use to make a career out of it. So that's just a very important overall point, is that this was not an immediate light bulb moment. It was really over the course of many months and really years to confirm that to myself.
I really appreciate you sharing that with us. And I think it's really important for people to understand that you didn't just, mortgage the house and go and do this really expensive education, that you had some experience first. You had already proven it out, decided that this is something you're really interested in. But I'm curious, because you came a long way just by, learning by doing, by experimenting and figuring it out yourself. What made you decide that, hey, I really need a formal education in this as a software engineer?
Yeah, that's a really good question, and probably one of the most important questions to someone in that position listening to this interview. I feel like if your goal is to become a software engineer, perhaps with a geospatial focus, and get offers from tech giants like Google or Apple, or a smaller tech company like Drone Deploy, graduate school or formal education is definitely not a strict prerequisite, but it does help in a few key ways. And I think if you can understand those key ways, then you'll be able to better prepare yourself and better compete with people who have gone that formal route. Really, I was thinking about this earlier, and there's like three distinct groups of people that you need to impress along this journey. And unfortunately, the characteristics needed to impress each of those groups, they're largely disjoint. They don't overlap with each other. So the first group, I would say, are the recruiters. You need to be attractive to recruiters just to get the interview in the first place. Having formal education, like a computer science degree, is an obvious signal to a recruiter that you're worth interviewing. And recruiters are not technical, right? So they rely on these signals because they lack the ability and the wherewithal to recognize a talented, self-taught engineer. So if you are self-taught, you just need to tip the scales in your favor a little bit. You'll want to ideally backfill your resume with maybe some part-time classwork, maybe contributions to some open source projects, maybe a cloud certification, something like that. But honestly, the easiest way to bypass recruiters entirely is networking. And I know it sounds icky for people who are fresh out of college. It just sounds a little weird, but it makes a huge difference. Instead of trying to meet the recruiter, you try to meet the hiring manager, because they're the people who are able to recognize self-taught talent at a conference or through a professional organization or something like that. So that's group number one, are the recruiters. The second group that you really need to impress, and this requires a different skill set, are the interviewers. For better or worse, the majority of software interviews, especially at the big tech companies, they involve answering these very arcane algorithms and data structure questions on a whiteboard or in like a virtual code editor. Now, computer science students who have elected to take the formal education route, they have to learn a lot of this very mathy, very theoretical material as part of their curriculum. But if you're self taught, you probably skipped over a lot of this theory because it's boring and honestly, it's not that useful day to day. So, in order to be able to impress those interviewers, you really just need to find a friend and practice these kinds of interview questions. There's an entire book called Cracking the Coding Interview, which is very popular for this. There are entire websites that have interactive code editors where you can practice these problems and see how you rank in the quality and performance of your code compared to other people on the platform. The most popular one is called Leet Code, and if you can answer the easy difficulty questions on Leet Code, you're in good shape. So that's group number two are the interviewers. The third group that you need to impress in order to succeed is your colleagues once you're on the job. Unlike the previous two, unlike the interviewers and unlike the recruiters, self-taught engineers are actually at an advantage here because they've had to develop resourcefulness, they've had to develop practicality that a fresh face college graduate hasn't necessarily had to develop. So if you're a bit older, you have that workplace experience, you really tend to excel in this category. It's just unfortunate that it comes after the interview and after talking to the recruiter. And this is just because CS graduates they're brilliant programmers, but schoolwork is contrived. It's done in a contrived environment. There's always a correct answer that's achievable in a reasonable amount of time. But we all know that this is often not the case in the workplace. Recent graduates also don't necessarily know how to work well with others in an office environment. I think the most common complaint among students back both in my master's program and in my undergrad was having to work on group projects, right? That's the worst. You're with a bunch of slackers and a bunch of procrastinators. Well, guess what? Real life office work is a giant group project. So you kind of have to learn to live with that. So these are all soft skills that a self taught engineer would carry with them from their days as a GIS analyst or whatever. So graduate school is, as I said, less of an advantage here. So it's perceived by each of these three groups, right? We have the recruiters first, then the interviewers second, and then your colleagues third. There are certainly benefits to having formal education in computer science, but they are not strict requirements. I guess that about half of the engineers at Drone Deploy do not have a degree in computer science, and yet they're just as likely to be critical team members, top contributors, and leaders.
Thanks very much for walking us through that. I think that those are some absolutely brilliant points. I really appreciate that. I hope the listeners take note of what you just said. Would you mind sharing how you document your skills? Do you have some sort of online profile, or do you point people towards a GitHub repository? How do you show what you've learned, the projects that you've been working on?
It really depends on who your audience is. If you're trying to impress a recruiter, then you're going to have to go the old school route and put together a resume. A lot of recruiters use automated software to look for keywords in resumes. So make sure to mention the different cloud platforms that you're using because recruiters often type these into their software without knowing what it is, right? They don't know what Kubernetes is, they don't know what AWS or S3 is. But if you have some experience in those areas, just mention it in the skills section of your resume. There's a lot of resources online about how to do technical resumes for software engineers. So I encourage you to look those up. But if your audience is a hiring manager, that's where a GitHub profile or an open source contribution or a technical blog post where you talk about how you implemented something, that's where that can be really more impressive. So you really got to know who the audience is and tailor your message appropriately.
This has got to be some of the best and most in-depth recruiting advice that I've ever heard. I really appreciate you walking us through it.
Happy to help.
I think a lot of people do this, right? We have this sort of built-in understanding in our minds that we go to university, we go to college, and that there will be a reward at the end of it because we are going to be investing, in many cases, several years of our lives and a bunch of money in getting this certificate at the end, this sort of proof that we have completed the curriculum. Was your payoff, was that going to be a personal interest one, or were you focused on the money? And I guess what I'm getting at here was it because you knew this was right for you, because it was going to lead you down a path that was going to take you towards interesting work and interesting projects? Or were you looking and seeing money? Okay, there is more money making opportunities if I go down this path.
Yeah, that's a very good question. I think there's always a little bit of both. I really saw the GIS analyst side of things as something that's very interesting, but didn't pay particularly well. And there wasn't a lot of growth opportunity either in responsibilities or in compensation. Whereas in the software engineering world, I really saw the potential to be a technical person and have a much higher ceiling in terms of kind of how high you could go. Now, inevitably, just for everyone listening, I think it's pretty clear that I ended up deciding to go the formal education route, and I went to a master's program in computer science. It was kind of after I had taken those part-time computer science classes, and I probably had the equivalent of a minor degree. But I applied to master's programs, not really knowing if I would get in because I had such a non-traditional background. Right, a lot of master's students come in with a bachelor's degree in CS already, and I just had a couple of courses, so I was kind of faking it. But I did end up getting in, and I decided to move to Pittsburgh, which is where Carnegie Mellon is, and just really, really go for it. Getting back to your question though, in terms of kind of what was motivating me for graduate school here, I think at that point I could have found a job where I could have leveraged both of my kind of skill sets, both my geospatial experience and the small amount of programming skills. I could have found that stepping stone job. All the companies and organizations and government agencies that have GIS teams that need geospatial problems solved, they typically can also benefit from programming expertise. And the decent ones will compensate you accordingly because there's so much demand for these skills out there. But I decided that and this is a key distinction here, I decided I did not want to be a GIS analyst with a specialization in programming. I wanted to be a software engineer who happened to have geospatial subject matter knowledge. They sound very familiar on the surface, but I felt that there was just a bit more job security, a bit more potential for growth on the software end of the spectrum rather than on the geospatial end of the spectrum. As I said, nowadays that distinction is a bit of a false dichotomy just because there's really cool data science and data engineering jobs that live in the gulf between those two extremes. But 6 or 7 years ago, it was a bit of a different story.
Oftentimes, when we talk about data, we have that saying in the geospatial world where 80% of all data has some kind of spatial component to it. When you think about software engineering now, like we're dealing with data, do you see geospatial as being an add-on to some fields, or is it just baked into all of the fields in some way, shape, or form?
Yeah, that's a very good question. I feel like it kind of goes back to the common mantra of is spatial special or not? Ultimately, well, to answer the first part of the question, I think there is spatial information all over the place, whether or not people know it. And that's what's really curious is that you have software engineers out there who are performing geocoding and they're doing things that are spatial analysis, but they don't think about it as such. There are software engineers out there who have probably used more Google Maps API credits than you have ever thought to, but they have never heard of what a GIS is. They don't know about that kind of software. So there's this weird, weird world where they're solving spatial problems, but they don't even realize what it is they're doing. And I think that's really a big opportunity for someone who has that geospatial expertise to lend some of that subject matter knowledge and really raise the stakes in terms of the quality of the analytics and thinking very thoughtfully about how to implement these tools in an efficient way and how to really go the extra mile in terms of the way they implement their software.
Could we spend just a bit of time on that? Because I think that's really interesting. Initially, when you were talking and you were saying, well, there's these software engineers that have used all these, geocode credits for Google, for example, they're solving all these geospatial problems. My mind went to, well, if it isn't broken, why fix it? And then you added that twist, and the twist was there was an opportunity here to come in and add value in terms of looking at the way things are happening, the processes, and saying, well, we could do it in another way, a more efficient way. We could use these other tools here, or we could make add-ons to this. We could also solve, XYZ problem. Do you have any sort of examples where you have seen this, perhaps in your own career, where you have shown up and looked at a problem with your, geospatial glasses on, your geospatial understanding, and said, I can see opportunity here?
Yeah, no, that's a really good question. After grad school, I ended up at Drone Deploy, which is a very geospatial product, right? It allows people to capture data, upload it to a cloud platform, and from there you can turn it into 2D orthomaps and 3D models and point clouds and panoramas. So it's very geospatial in nature, and I've definitely had opportunities at Drone Deploy to do exactly that, to really leverage my spatial experience. One particular example is in multispectral data. My undergrad research was all about looking at near infrared data from satellites and looking at vegetation indices over time, really classic Earth observation, remote sensing 101 type topics. And a couple of years ago, someone came out with a drone that had a 5 band sensor on it, where it had a narrow band, red, green, blue, it had a red edge band, and it had a near infrared band. And the world of programmers, like I said before, they kind of have this passing knowledge of geospatial topics, but it's definitely not an in-depth sense. And sometimes those engineers won't even know what to search for. So the idea of having 5 bands of color or false color was just mind-blowing to them, right? They couldn't really they didn't really know how to proceed with that. So one particular example is we wanted to allow customers to have both a true color tile pyramid, a true color ortho map, as well as a false color one that incorporated the red edge and near infrared. And I kind of knew that all of the image formats out there are designed for three bands, right? JPEG typically only allows you to do red, green, and blue, and PNG only allows you to do red, green, blue, and alpha. So it's just a matter of thinking about, okay, how can we take these five bands of multispectral data and distribute them among the kind of three slots that we have? And the solution that I designed was to create two separate ortho maps. You have one which is true color and one which is false color, and you can switch between them as necessary, but at least it allows you to continue using common image formats like JPEG and PNG without having to reinvent the wheel or do some crazy TIFF thing or something like that. That's an example of where my GIS and remote sensing background was really an asset in doing the technical design for a project that was getting very GIS-y and very spatially.
Yeah, I think that's a really good example. I also like what you said there that software engineers working in this space who perhaps don't have that same spatial understanding as what you do, they wouldn't even know what to search for. And that is so key when we talk about a new vertical is having that vocabulary, knowing the words to use, knowing the questions to ask, and that sort of opens up a whole bunch of doors for people. I think that's a really important point that you mentioned there.
Yeah, no, knowing what to search for a lot of times is half the battle, and that's one of the places where having a formal education can come to bear, is saying being able to articulate a question and put it into Google search. Yeah, that's a really key skill to have.
And also, I'm assuming in terms of communication with colleagues, with subject matter experts. Hey, like we both talk the same language, we can understand each other. I'd like to sort of move off now and talk about the idea of low code, no code. Right at the start of this conversation, you talked about that this was kind of your entry point into software engineering. You were using Model Builder, and this is definitely a low code, no code example, which the drag drop interface. We chain together these processes, and you can export that as you can run it as that visual process that you see, or you can export it to something like a Python script and run it that way. Do you see this trend towards low code, no code? Is that in any way going to encroach on what software engineers are doing? Is this going to be a viable middle path for GIS analysts, do you think, to sort of cross over the chasm?
Yeah, that's a really good question because there has been a lot of growth in low code, no code solutions. I think it's so fascinating to see products that in a lot of ways look like Model Builder, but obviously have a lot more capabilities and are a lot nicer looking. To me, there is no threat from low code, no code applications for the software engineers because it takes so many software engineers just to build one of these platforms. And there's so much demand for software engineers in general that I'm not the least bit concerned about low code, no code. The group that I would be more worried about are the analysts, because there's a lot of analysts out there where part of their work is really just following these recipes that they know for making maps, for doing very basic analyses, for doing just a simple spatial join, right? Even if some decision maker doesn't know what it's called, a lot of times that's what they're trying to do. They're trying to take two different data sets and they want to get the attributes from one joined to the other. So I think for the GIS analysts out there, I think to learn about the low code, no code solutions so that they can automate those processes for themselves. And because that is going to be a threat to part of their billable hours in terms of what they're doing for the decision makers. Part of what we do at Drone Deploy is we try to simplify the process of collecting and processing drone imagery. And in the past, that's something that really took a lot of expertise, and there was very sophisticated software that you had to use. It really required you to have like a kind of a department of people who really knew that software inside and out. What we're trying to do is we're trying to simplify that process so that if you are competent enough to just fly the drone, then you should be able to get that 2D ortho map and that 3D model and that 3D point cloud without any special training, without any expertise. So I honestly think that Drone Deploy is kind of one of those companies trying to do that no code product, even if we don't call it that at face value.
I talk to a lot of companies that are doing similar work to Drone Deploy in that they're talking about democratizing access to things, lowering the barriers to entry to access to things. And oftentimes, if you're a GIS analyst, it might feel like your position is being slowly but surely eroded. Do you think there's a natural ceiling to these low code, no code solutions to this democratization of stuff? Because one of the arguments for programming is that you have full control, right? And if you are using low code, no code solutions, you're never going to have full control. Somebody has made decisions for you. Do you have any idea where that ceiling is going to sort of lie in terms of what we can do and what we can't do with low code, no code solutions?
So I think the best low code, no code solutions out there allow you to pull back the curtain and see the code that's being generated. Because ultimately, no matter what the user interface looks like, there is computer code being executed. It's just a matter of is there an interface on top where they gussy it all up and they make it a little less intimidating than actually having real computer code. So, for example, earlier I was talking about how Model Builder always allowed you to export to Python. There was no permanent connection, though. You couldn't go back from Python into Model Builder. But there are some low code, no code solutions where you can seamlessly switch between the two and say, okay, show me the underlying code, and maybe I want to make one little tweak in here, and then go back to the draggy droppy view where I just have nice bubbles and lines connecting them. So I think in that sense, there really isn't a ceiling. There's actually a very natural progression from the user interface into a coding environment. And I think those are really the best solutions and the ones that are going to be most long lasting in the industry.
Do you think that if I'm going to continue my career, for example, as an analyst, that I need to have an understanding of code if I'm going to work on any sort of technical problem solving?
I won't speak for everyone because there's such diversity of GIS users and GIS analysts out there. It's one of the things I really miss about conferences is you meet people using GIS for archaeology and for ecology and for all these fields that you don't typically think of. So I think it would be presumptuous for me to say this is what an analyst has to do or this is what they should not do. But I think that having an understanding of what you can and can't do with code and ideally knowing a little bit of yourself will be a major service to you in terms of automating your work, making yourself faster, and just as a little bit of like a safety net, because it'll just be harder to get rid of someone who really has a deep understanding of that code. It's really a lot of job security having that understanding.
I think that was an absolutely brilliant answer. Thank you very much. I really appreciate that. Right at the start, we talked about, so you had the sort of desire to stay within the technical field of GIS and solve these technical problems, and you weren't interested in moving up into more of the management hierarchy of things. Do you see yourself now as a software engineer? Will you somehow find yourself in the same situation in a couple of years' time, where in order to progress, to get promoted, you're going to need to move into management or into a leadership role, or does that look different in terms of software engineering?
That's a really good question. And the answer, of course, is that it depends. Just like before, one way to move up is by going into management. So instead of doing the programming yourself, you might be managing the teams that are doing the programming. So that's exactly like before. And that's what I wanted to avoid doing back when I was a GIS analyst at this consulting company. However, there is an alternate path, and this is not ubiquitous, but at some companies, especially very software focused tech companies, there's this separate thing called the individual contributor track or IC track. That's what people in the industry call it. The IC track that would allow you to move up in terms of responsibilities and compensation without ever having to manage a team of direct reports. You get to focus on the programming. Now, partway up this ladder, there's kind of a mid-level role, which is technical lead, or different companies have different names for it, but that's one of the more common names. That's what I personally am aiming for next. Tech leads still do plenty of programming, but they're more heavily involved in designing how new features will be implemented. And they also often serve as a go-to person for a portion of the code base, just like an in-house subject matter expert. At Drone Deploy, as I said, I'm already the go-to person for a bunch of the very wonky geospatially topics like the multispectral work that I talked about before, coordinate systems, of course. Everyone still hates coordinate systems, even in the software world. Ingesting shape files and DXF files, etc. So I already kind of have a little bit of that, but yeah, that's kind of what I'm aiming for next. Now, if you keep going up, there are even more senior roles like staff engineer, staff architect, principal engineer. In terms of compensations, these roles they are equivalent to directors and vice presidents on the management track, but except these roles, since they're on the IC track, they're focused on high level technical aspects and not on managing teams or managing people. So the IC track is really cool, but as I said, it's not everywhere. It's going to be much more common at companies whose end product is software. So if you're a kind of a GIS analyst with a specialization in programming, and your company is either a consultancy or maybe your company has a totally different end product, maybe you're at an electric utility or something like that, then it's a little less likely that they're going to have the engineering culture and the wherewithal to have an individual contributor track. But only less likely. It's not impossible. It would be presumptuous of me to say one way or the other.
That's really interesting. I didn't realize that the software world worked like that. I used to work for a company here in Denmark, and they had two separate tracks, and it was like leadership and specialist. It was pretty simple. But the idea here, in terms of being a GIS analyst, that was that you could carry on down that specialist track if that's what you were interested in, and become very, very focused on extremely specific problems and be the specialist within the company for those particular problems or those particular areas of interest. And I thought that was a really good way of handling it and providing that sort of progression in people's careers if they were interested.
Yeah, the only downside of that kind of specialization is that it ends up being very narrow. And I remember seeing this at my old job where we had some people who were real specialists at using a particular kind of flood model, right? They had papers published in that, they were experts at it. But what if that model gets replaced by a different model? Or what if the funding dries up or something? There's a lot riding on that very narrow specialization. What's a bit different about individual contributors in a software world is that at the high level, when you're at a technical lead or you're at a staff engineer or you're at a principal engineer level, your your purview is actually very wide. You're thinking very holistically about how are all of the different systems in your architecture going to talk to one another, and how should we redesign them because we have a new product that's going to have a different workload on them and so on. So I agree that it sounds really great that they have this specialist track, but the individual contributor track in software is broad as opposed to narrow.
Yeah, I can see too when you become too specialist. I mean, the work could very quickly become quite repetitive. And I've definitely experienced that during my consultancy career. So, working as the very beautiful title of geospatial specialist or geospatial consultant, oftentimes it means that you're doing a lot of repetitive tasks.
And those are the repetitive tasks that are perfect for automating with some kind of programming language or scripting language or something like that.
Hey, I've really appreciated the conversation so far. I really enjoyed it. It's been an interesting look into the world of software engineering, a world that I'm not completely familiar with. So this has been great. I've got a couple of final questions before I let you go. And the first one is, are you still using Python in your day-to-day work, or have you moved over to another language?
Yeah, so I am still using Python, but that is a coincidence more than anything. I learned Python way back in 2011 because that was the easiest way to write custom processing, geoprocessing tools for ArcGIS. Python has continued to be very popular because it has a relatively friendly syntax and because the data science, data engineering world has grown so much. But just in graduate school, I learned Java, I learned JavaScript, I learned MATLAB, I learned C, C++. I've learned all these other languages, and I had job offers to go to companies to work in some of those other languages. So I'm a software engineer. I'm not just a Python engineer. And that's actually a point that I would like to make for people who are thinking about dipping their toes into this field. The choice of your first programming language is not a crossroads. It's not like a video game where you have to pick wizard or warrior and then you're stuck with that decision forever. They're really more like dialects of computer science rather than separate languages. I think people have an association with languages being something that takes years to learn and you only focus on one. It's definitely not the case. So, yeah, to people who are thinking about learning to program, don't dwell on the decision of your first programming language. Just pick one that's going to be useful to you and get started. It's easy to pick up new languages after your first.
Could we make any kind of comparison here between something like ArcGIS and QGIS, where I would argue definitely that it's the concepts, it's the spatial concepts and your understanding of what's happening when you chain together these processes that makes the difference, which means that I can take those same spatial concepts and to a new piece of software, let's say moving from QGIS to Esri, and use them over there. Is that a useful sort of understanding of how we should perhaps think about programming languages?
Yeah, to an extent, I think that there's there's a lot of concepts and a lot of abstract ideas in QGIS or ArcGIS or any other desktop GIS software package. And in the same way, yes, there are common ideas between modern high-level programming languages. They all have variables, they all have loops, they all have conditionals, they have classes, they have functions, and so on. The syntax will vary between these programming languages, just like the user interface might vary between ArcGIS and QGIS. But I think the one of the real big differences between programming languages is their ecosystem. And you always have a lot of great guests who are from different parts of the geospatial ecosystem. And each programming language has its own ecosystem as well in terms of the open source libraries that people write for it. So that is something where I don't know if there's a good corollary in this metaphor, but yeah, it's once you learn one GIS package, it's relatively easy to switch to another. And yeah, I'd say the same is true with programming languages as well.
Dan, I really want to thank you for your time. Again, you've given us this amazing look into the world of software engineering from a geospatial perspective that I've really enjoyed. So thank you very much for that. If there's a listener out there that's thinking, hey, I would like to go down this track, I would like to do something similar, is there some way they can reach out to you or get in touch with you?
Yeah, so I'm on Twitter. I'm not particularly active. I kind of lurk, but I'm at DMAR on Twitter.
Thanks again. I'll include that in the show notes.
Likewise, it was my pleasure, Daniel.
Thanks again to Pictera for sponsoring this podcast episode. I did an interview with one of the machine learning experts at Pictera some time ago. The episode was called Object Detection and Machine Learning for the Rest of Us, and they had this amazing use case, and the use case was extracting objects from a web map service in Denmark. So I'm based in Denmark. Yeah, obviously this was interesting to me, but I had never thought of using a web map service in this way before. To me, it was a way of hiding data. Say, you can look but don't touch. But using Pictera's technology, you can extract objects from web map services, and I thought this was absolutely brilliant. If you are interested in this or want to check it out, go to Pictera, that's PICTERRA.ch. I just want to take a few minutes here to highlight a few of the things that I found particularly interesting about this conversation with Dan. Firstly, I thought he gave some really, really great advice in terms of recruiting. And for me, the key to the advice was have empathy for the person who is doing the recruiting. You know, what stage of the journey are you at? How are you applying? And what kind of information do they see? Do they need to see? And for me anyway, it was all about tailoring the message. So who is it that's going to read this? Who is going to be looking at this? Who needs to make a judgment call based on this information? And how do I tailor it to them in terms of where they are in the recruiting chain? I thought Dan gave some brilliant advice with respect to that. On a much more general note, I want to say that I personally really admire people like Dan, people that realize that their career isn't taking them where they want to go, or they don't see the opportunities that they really want to have, and do something about it. I think too often it's easy to become stuck in our careers, stuck in geospatial. Perhaps we reach a point where we realize that this is not the path that we want to be on, but that the sunk costs, that build-up of professional capital that we have acquired over the years, it's really difficult to turn our backs on that and say, I don't want to be like this anymore. I don't want to be on this path anymore. I'm going to try something new. And the scariest thing about trying something new is that it may not work. So I have experienced this personally in my career, and I'm almost embarrassed to say that it took me a long time to understand that I was better to try something that may not work than to stay in a position where I knew it wasn't working. So I really hope you enjoyed that conversation with Dan. I think it's really interesting to hear a person moving from that GIS analyst role to a software engineer role. And I think if I could find someone out there that had gone the other way, so move from a software engineering role to perhaps more a front-facing role or a leadership role, that might be a really interesting story to tell as well. So if that's you, if you have a story to tell, if you've been in that position, made that pivot, I would really love to hear from you. And that's it for another episode of the Mapscaping Podcast. My name is Daniel. It's been a pleasure being your host again this week. Thank you so much for tuning in. As always, you are more than welcome to reach out to me on all of the channels. Also check out our website, mapscaping.com. And if you could do me one small favor, that would be to please share this episode with a friend. I would really appreciate that. Thanks again. We'll talk again next week. Bye.